Alright, we're going to work through number 1 and number 7 together on this handout. So then you can use those examples to finish them. We'll start with number 7. Go ahead and read it to yourself. And now let's work through it on the back. So the mass of the boater is 60 kilograms. And the boat is a 100 kilogram boat. So we're going to put 60 in for the mass of object 1 and 100 for the mass of object 2. We know that the initial velocity of each of them, or both of them, is 0. Because they're at rest. So we're going to calculate momentum as the mass times velocity. So 60 times 0 will give us 0, 100 times 0 will give us 0, 0 plus 0 gives us 0. So the total momentum of this system is 0. Now the boater steps off, and we're going to copy and paste these two values for mass over to the after side. Now the velocity of the boater going away from the boat is 2 meters per second. And we are asked to find out what is the velocity of the boat recoiling away in the opposite direction. Because we don't know that, and that's what we're trying to find, we're going to put in a v as a variable. Now let's work through the math. 60 times 2 is going to give us 120, and the units are going to be kilogram times meters per second. And for the other part here, 100 kilograms times v, well, that's just going to be 100 kilogram times v. We cannot multiply or do anything more with that. Now we would have the step where we add them together to find the total momentum. 120 plus 100 times v. Because the 120 does not have a v, we cannot add them together. So we're going to rewrite it underneath here. And when I write it this time, I'm just going to leave the units out because that will make the algebra steps easier to focus on. So we have 120 plus 100v. And now we need to go through the steps of solving this equation. So the first thing we're going to need to do is get rid of the 120 from the right side by subtracting both sides, or 120s from both sides. So now we have negative 120 equals 0 plus 100v. Alright, so now we have our next algebra step, which would be to divide both sides by v. Divide both sides by 100. So the hundreds are going to cancel out here. And we have v equals 120 over 100, which is 1.2. And I should be aware that there's a negative sign here, so it's going to be negative 1.2. And I'm also going to make sure I include units for my answer here. So the units are going to be the same units that I had for the original velocity of 2 meters per second. So it's going to be negative 1.2 meters per second. And I'm going to put a box around that final answer. I'm going to do a little reality check for myself. Does this number seem like number 1 is going in the right direction? So they should be going in opposite directions. So this is positive and this one's negative. That checks. And I know the boat is heavier, so I would expect it to have less velocity because it has more mass. Let's take a look now at number 1 on your paper. So in number 1 we have a great white shark. You can go ahead and read it yourself. You can pause it. In this case we have two objects colliding. And what's implied with all of these is that there's no friction or other water resistance, that it's just one object coasting into another object. So the only force that's occurring here is the force of the two objects as they hit each other. So it's a bit of an assumption, but it's kind of an exercise that we're working through. Okay, so we're going to call shark our first object, and its mass is 300 kilograms. And that means the other object is the tuna, which is 50 kilograms. And the shark is moving with a velocity of 2 meters per second. The tuna is moving toward it with a speed of 0.5 meters per second. But here's one thing you have to be very careful of. Because it's swimming toward it, it's going to be a negative. So they're going in opposite directions toward each other. Alright, now let's do the math to find the momentum. 300 times 2 would be 600. And I'm going to take this opportunity to just use numbers. I'm going to leave out the units. It'll make the math a little easier to work through. 50 times negative 0.5 is going to be negative 25. When I add these two momentum together, momenta, plural, is 575. So that's how much total momentum there is in this system. If I go over to after the tuna is absorbed by the shark is still going to have a mass of 300 kilograms. The tuna is still going to be a 50 kilogram tuna, only now it's going to be inside the shark. The new velocity that they're going to move with, we don't know. And that's the question that was posed to us in the problem. So we're going to put a v as the variable that we're going to solve. So to find the momentum, we can do 300 times v and 50 times v. This time, both of these terms have a v, so they are like terms, so we can add them together. 300v plus 50v is 350v. Now we have to do one algebra step in order to solve for v, and that algebra step is to divide both sides by 350. I'm using green just to show an algebra step. Alright, so what is 575 divided by 350? And for that we get 1.64, and this is v that we're calculating. So we know that the units are going to be whatever unit we had for velocity originally, meters per second. Alright, so at this point here I'm going to do a reality check. Does my number seem to be about the right size? Does it seem like it's positive when it should be positive? And so imagine a big shark coming along. It has a smaller object collide into it, which is going to have the effect of slowing it down. So it went from 2 to 1.64. Okay, that seems reasonable. This answer is smaller than 2. And it's going in the same direction as we would expect, so it's positive. Okay, so it seems like it checks, seems like it works out. Before we end here, I want to get you started on number 3, because number 3 is a little different because you're solving for mass and not velocity. So go ahead and read that to yourself. So this time, to continue these problems, you're going to be doing your work on your own piece of paper. So you can make a very simple table like this: before, after, and MVP, mass, velocity, momentum. So what do we know here about this? We know Bertha, whose mass is 50 kilograms. So we're going to put in 50 kilograms for her. And we can go ahead and copy and paste that right over to here because her mass is not going to be changing. And her grandchild, what is his mass, is the question it asks for us. So for that one here, we can put in an m. That's going to be the variable that we end up solving for. And I think from here you can continue it with in a similar fashion as we did the others. Thanks for tuning in.